Alright, so let's put this together. Let's find the slope and the y-intercept of a linear function using this word problem right here. Okay, we're going to learn how to write an equation for a linear function using the idea that m is going to be our slope and b is going to be our y-intercept in our equation y equals mx plus b. First, we're going to ask ourselves, what is this problem about? Then we're going to ask ourselves, what are we trying to find out? And last, we're going to ask ourselves, what information is important? So let's read that problem on page 80. And then remember, we're going to use our y equals mx plus b equation in order to help us better solve the problem. It says, Tony's taxi charges $3 to pick up a passenger, plus $2.50 for each mile. Write an equation for the function that relates to the total cost of a trip to the distance. Also identify the slope and the y-intercept of the function. So what's the first thing this problem is asking for? I'm sorry, what is this problem about? It's about Tony's taxi charges. What are we trying to find out? Usually we're looking for a verb, or we're looking for something with a question. In this case, we're going to write an equation, and we are also identifying the slope, okay, that's my m, and the y-intercept, that's my b, of the function. And I know that it's going to cost $3 to pick up a passenger, plus $2.50 for each mile. We can solve by first creating a table. Once the table is created, try calculating the difference between consecutive y values, like 5.5 minus 3, 8 minus 5.5, 10.5 minus 8, 13, minus 10.5, and 15.5 minus 13. This should give us a constant rate of increase of 2.5. Next, we graph what's on this table. So my first point, my initial value, or my initial plot, is 0, 3, which is right here. 1 and 5.5. So I go up 1 and plot at 5.5 for my y value. Then I plot 2, 8. So I go to 2 at my distance and $8. Then I go to 3 miles and $10.50. Then at 4 miles, it's $13. And at 5 miles, it's $15.50. This graph shows an increase where x increases by 1, but look at my pattern. Remember we talked about that? If there's a pattern, that probably means it's a linear function. And here's my pattern. If I add $2.50, I get $5.50. If I add $2.50, I get $8. If I add $2.50, I get $10.50. If I add $2.50, I get $13. If I add if I add $2.50 to $13, I have $15.50. So notice how my rate never changes. So my y-intercept, again, is where this line hits my y-axis. And where does this line hit my y-axis? It hits it at 3, right? So my y is 3 and my x is 0. So wherever this line hits my y-axis, that's my y-intercept. So my point where this point hits is 0, 3. My slope is how much this changes here on my table over how often it changes. My rise over run, my change in my y over my change in my x. So the reason why we make these tables is because the table on the graph helps us find our slope. We can divide our rise by our run on the graph, or use the formula y2 minus y1 over x2 minus x1, and use the 2 points on the graph for the slope. So the slope is the increase in cost. So the more something costs, the longer your miles go. We can use the table or the graph to find our y-intercept. What does the y-intercept represent in the problem? Our y-intercept right here is 3. So that means our y-intercept is the y-coordinate that's paired with x equals 0. So our y-intercept represents that cost of being picked up by the taxi, our initial value. In our equation y equals mx plus b, which value represents our slope? Let's take a look. Our m is our slope, and our y-intercept is our b. So let's substitute our m and our b for the values in this problem. Our y is going to equal 2.5x plus 3. Now let's check our equation by evaluating a number into there. Any number, our y value should be this, our output should be the same as what we put on our table. So this matches the table right here, 5.5.